Today we're going to do Unit 1, Section 5, Transformations of Linear and Absolute Value Functions. So here we're going to be a lot more specific on actual transformations. So I've split this into different sections so we can focus on one at a time. The first section is translate a function. Of course, translate is left, right, up, and down. So before we get into the questions, we'll go ahead and write some notes. If I have y equals, in parentheses, x plus some number, I'm going to shift to the left. So if I want to go left, I add inside the parentheses. Of course, if I do x minus some number, I'm going to shift right, just the opposite. So left and right has to be with x in parentheses, or it can be within absolute value if we have that. So the other way is up and down. If I want to go up, I would add some number outside of x or at the very end of the function. And then of course if I want to shift down, I'm going to subtract from the outside or the end of the function, so away from x. Okay, so I have left, right, up, and down. Now for the notes. It says I have a function 3x minus 4 and I want to translate right 3 units. Of course, if I want to go right, I'm going to look at this one right here and notice I have to subtract in parentheses. So I'm going to rewrite the function, except now since x is not in parentheses, I'm going to add that, and I'm translating right 3 units. Just like that. Because to shift left or right, I have to have a number in parentheses with x. If I don't have parentheses, you have to add them. Now, from here, I'm able to distribute real quick. And I would have 3x minus 9 minus 4. And then combine like terms of these two. My final answer would be 3x minus 13. And that's number 1. Number 2, I have a function, the absolute value of 3x minus 4, translated left 3 units. So again, left is in parentheses with x, or in parentheses with x, or inside absolute value bars. So for this one, since we already have absolute value, we're just going to write 3x minus 4, and then left 3, so minus 3. Sorry, plus 3, because I want to go right. So, because it's absolute value, I want to just add a number inside the absolute value. Now from here, I just combine like terms right here. So my answer would be y equals absolute value 3x minus 1. So similar things, but totally different. So if I have an absolute value and I move left to right, I just put the number in the absolute value. If I have a linear equation like this one, where I don't have parentheses and I move left to right, I have to add parentheses to do that. So I know this gets a little tricky, but you just got to be careful. Alright, let's go down here. Now this one, it gives me 2 graphs, and I want to know the transformation from f to g. So I'm going to start on the blue line, and I want to get to the red line. So in these, I can go ahead and write my equation first at the blue line. So I have y equals my slope on here. If I start at one point and go to the next, is just up 1 over 1. So my slope is 1x, and my b is -3. So that's what I started with. And then let's write the g so I can see what I got to get to and what changes. So again, my slope is up and over. It's still 1. So I still have 1x, but now I have my b is changed plus 1. So to describe the transformation, all I have to know is, what did I do to get from -3 to +1? Well, on the graph, it kind of helps you on these. I can easily count. So from this -3, I go up 1, 2, 3, 4. So my transformation is just shift up 4. And that's all I got to write. Since I didn't do anything else, that would be my whole answer. So linear equations are far easier than most others when doing this. Okay, number 4. Now we have an absolute value. Same thing, it's just a v. So I'm going to go from F to G, so from blue to red. So I'm going to go ahead and write my blue, y equals absolute value. Now my slope, again, same thing, up 1 over 1, so it's just 1x. And then I go from the center. So from the center, I moved 1, 2, 3 to the left. So I moved 3 to the left, and then I moved 1, 2 down to get to my vertex, or my center. So that's my blue equation. Now I can do the same thing with my red one and see how they're different. So my red one is y equals absolute value. My slope is still up 1 over 1, so 1x. Now from the center, I gotta start from the center again. I move 1 to the right, so -1, and then up 1. So since I'm just translating right now, these are fairly easy to do with the graph. But say you didn't have a graph, I want to know how I go from +3 to -1, and how I go from -2 to +1. So remember, inside with x is left and right, outside of x is up and down. But we have a graph, so I'm going to go ahead and use it. So I start from the blue vertex, or where it turns, and I want to get to the red one. So if I'm talking about translating left, right, up, and down, I can go either order, it doesn't matter. So I go, well, 1, 2, 3, 4 to the right, and 1, 2, 3 up. So my answer is shift right 4 and shift up 3. So again, I have a graph to make this easier, but if I didn't, I could just look at the functions over here and go from 3 to -1 and -2 to +1, and I would get the same answer. But the graph definitely helps. Okay, moving on. Now we're going to be on reflect. So reflections, we have 2 reflections. You can reflect over the x-axis and you can reflect over y. So to reflect over y, let's do that one first. Or I'm sorry, let's do x first. So reflect over x-axis. I would have to do like y equals and then negative in the front, and then parentheses, and any x plus any number or whatever you have, the whole thing has to be negative. So you would distribute the whole thing. Now there is an exception to this with absolute value. I would do negative parentheses and then absolute value of x. plus whatever number. And so typically I would distribute like this on the left. I would distribute this negative to everything in my function, and that would switch it. On the absolute value, this negative would just go in the front here and then distribute to any numbers after, because I can't change inside the absolute value. If that makes any sense. Hopefully it will. If not, I'm pretty sure we have an example for this, so we will show you. The other way is reflecting over y-axis. So this one, when I do my new equation or my new function, I'm just going to change x and nothing else. So my negative now only changes x. It doesn't change every single number. So for absolute value, I would just have my absolute value and then change x on the inside, and it wouldn't affect everything. So hopefully that seems, oh, I forgot the r back here. Wow, you don't need to tell me that. That's okay. We got it. We're fixed. If you were hyperventilating over misspelled errors, it's a good thing I'm a math teacher, but we got it. We're good. So let's do number 5. I have a function 1/2 x plus 3 that's reflected over the x-axis. So again, if I reflect over x, I'm going to do this first one down here where I take my negative and distribute it to everything inside. So I'm going to go ahead and write y equals negative and then big parentheses, write my whole function, and to finish, I just take that negative and distribute it to everything inside the parentheses, and I'm done. So my answer would be y equals negative 1/2 x minus 3. Alright, so that wasn't too bad. Number 6. Now I'm reflecting over the y-axis. So remember, if I reflect over y, I only change the x. So I'm going to have y equals, there's already a negative there, so negative, parentheses, and then I can do like 2 negative x, right? Because remember, I only want to change x. So now I can clean this up a little bit, so I have 2 times negative x, and I can change that. So I have y equals negative 2 times negative x is negative 2x. Now, I mean, if you leave it like that, I understand, that totally makes sense, and that's okay. I'm going to go one step further though, because I only have one term in the absolute value, and as we know, all absolute values turn every number to positive. So if I only have one thing in there, I know it's going to be positive. It'll never be negative. So if you wanted to, you could say y equals negative absolute value 2x. So it actually ends up being the same thing that it was before. And if you saw a graph of this, it would totally make sense why it does that. But again, either way is fine with me. I just wanted to let you know that technically, because it's one term, one thing, that you can change it back positive and it's still fine. It's the right answer. So either one's fine. So that's reflecting the function. Now we can go to the graph. Now these I'm not even going to write out, only because these are a lot easier to tell which axis I'm reflecting over. Because you don't really need to write these out. So I mean, we can real quick if we want to. So like the first one, again, I'm going from blue to red. So my f function is y equals, my slope is still up 1 over 1, so 1x. My b is negative 1. So that's my blue one. My y one is y equals, my slope is down 1 over 1, so negative 1x. And my b is plus 1. So looking at the graph though, I can tell that I have reflected over the x-axis clearly, right? I'm going up on the blue one, then I'm going down and it pivots on that 1. But also, if I look at my functions, notice how this 1x becomes -1, and this -1 becomes +1. So if everything switches signs, it's x-axis. So our answer is just going to be reflect over x-axis. So I can use the graph to see that. I can use the functions to see that. Either way, I'm covered. And this one is, I mean, it's kind of the same thing. I can clearly see from the picture that I'm reflecting over this, but just to show you, the first one. So I'm from the center, right? I'm going over 1, 2, and up. So I'm going left 2, up 1. So I have absolute value of my slope is 1 still. So 1x plus 2 plus 1. And then my red one is y equals absolute value. My slope is negative now, right? Or the whole thing is negative, sorry. Negative 1x. I'll just rewrite that, sorry. I'm going down. Absolute value is negative. Slope is still 1. And from the center, I go left 2, down 1. So I still go plus 2, but now I go -1. So notice, here's the big difference. My absolute value in the front, there's no sign making it positive, and now it switches to negative. Because remember, we can't change inside the absolute value. But then my +1 on the end changes to -1. So everything changes in signs, which would make it x-axis. So with or without the graph, I can still figure this out. It's really hard to show reflections on the y-axis for some things just because it's the exact same picture, and I didn't want to confuse anybody, which is why I showed 2 x's. So that's reflection. Okay, now we're going to do stretch. So I'm going to make stuff bigger, right? Like Stretch Armstrong back in the day. So let's do stretching. Now there are 2 kinds of stretches. I only focus on one because the other one is actually just the opposite of compressed. I don't want to do that. So I only do vertical stretch, vertical compress. I don't do horizontal because the horizontal is the opposite. So I mean, technically vertical stretch is the same thing as horizontal compress, but I would not rather confuse you, so I'm just going to leave it as vertical only. I'm not doing horizontal at all. So for vertical stretch, if I had y equals, I would have some number in the front, a times everything, right? And then again, I would have to distribute that a to everything in the function. So for a vertical stretch, I multiply the whole function by a, and just the same, I can do y equals a, and then absolute value x plus c. So same thing. And again, just like the negative, when I distribute this a on the absolute value, it has to just go in front of the absolute value. I can't go inside the absolute value. And then I would go to the number outside if I have one. Now the only catch to this is my a must be greater than 1, and I mean, it's the absolute value, but anyways, so a, the number a, must be greater than 1, and you ignore the negative when you look at that. So like -3, I ignore the negative, and I just look at 3. 3 is bigger than 1, it would be a stretch. That was a weird G. Here, let's rewrite, oh, okay, let's rewrite G and A. There we go. So ignore the negative when you look at this, but a has to be bigger than 1. So let's look at number 9. I have a function, 4x minus 1. It's vertically stretched by a factor of 2. So whatever your factor is, that's what you multiply by. So I'm going to do y equals, so I throw that 2, that factor in front, parentheses, and then write my entire function, 4x minus 1. From here, I just distribute my 2, and I have my answer. Y equals 8x minus 2. And I'm done. Pretty simple. Okay. Let's go to 10. Same thing. I have my absolute value function. I'm stretching by a factor of 3. So now I just throw a 3 in the front of everything and distribute. So I have my 3 parentheses, absolute value x plus 1, and that's hard to see. Looks like 1x, it's absolute value. Minus 4. And I can distribute this 3. Remember, the 3 for absolute value, I don't go into the absolute value. I can't do that. Okay? So please don't do that. I have to leave absolute value alone. Oh, got rid of one more thing. So on this one, I throw my 3 in the front, and then I can make the 3 times negative 4. Okay? So I'd have y equals, again, 3 absolute value, x plus 1. Can't change that. And then I can do 3 times negative 4, minus 12. That would be my answer. Okay. So let's go down here. Describe transformation. So again, I'm going from blue to red, from F to G. So I'm going to go ahead and write these out because I think these would help. So my first one, y equals, my slope here is up 1 over 1, 2, 3. And then my b is plus 1. Okay. Then my red one, y equals, my slope here is up 1 over 1, so 1x. And my b is plus 3. Now, for stretching like this, I can look at either one of these. So I can say I go from 1/3 to 1, or I go from 1 to 3. To me, it's easier to do whole numbers if you can. So all you got to figure out is, what did I multiply by, or multiply 1 by, to get 3? Well, easily that's 3, right? 1 times 3 is 3. And if you were doing the fraction to check, 3 times 1/3 is 1. So that it works out either way. But I would focus on the whole numbers if you can. It's easier that way. So all you're doing here is figuring out what I multiply by the first one, the blue one, to get the second one. So I'm just going to say, because it's 3, we're going to do stretch by 3. And you can write stretch by factor of 3, it's fine. You can do vertical stretch. Again, I'm only doing vertical, I'm not doing horizontal, so we don't have to worry about that. So stretch by 3, that's all we did. Okay, 12. Okay, I'm going to go ahead and write the blue one, y equals. Notice I'm right in the center, I didn't move anywhere, that's great. So I need to find my slope for x. My slope for blue is up 1 over 1, so absolute value of 1x. And I don't plus or minus anything, I didn't go anywhere. Okay, so red, same thing, y equals. I'm still in the center, but now my slope is up 1, 2, 3 over 1. So my slope is 3x. Oh, look at that. So what did I go, or what did I multiply by 1 to get 3? Well, again, this is 3. So I'm still stretching by 3. So before, I wasn't really picky about the numbers, but now the numbers definitely matter. So you have to know what you stretch by, what you translate left, right, up, down. You got to know the numbers. Okay. So last thing on here for today is compress. There it is. So we've translated, we've reflected, we've stretched. Now we got to compress, make things smaller. So let's write the notes real quick for this part. So if I want to compress, and again, I'm only doing vertical, but I'll go ahead and write vertical or compress. So in vertical compress, I'm going to do, it looks the same actually. So I'm going to have some number a times the whole thing, where I would then distribute, if I need to. And the same with absolute value. I have some a times absolute value of x plus c. And again, on absolute value, when I distribute, that a just goes in front. I can't put it inside. Okay. Now here's the thing about compress, is a is smaller than 1, or less than 1 if you want to do that. I don't know why I wrote the words out, but that's okay. Smaller than 1. And then again, ignore the negative. So yeah, negative 2 is smaller than 1, but if I get rid of the negative, 2 is bigger than 1, and that would be a stretch. So I want to be careful about that. I will say, for the most part, or I guess always, this would always be true, every compress is going to be a fraction. Not every stretch is a whole number though, because you can have fractions bigger than 1. But every compress must be a fraction, because you're dividing. I'm getting smaller. I have to. Alright, so let's show this as an example. 13, I have 4x minus 1, and I'm compressing by 2. So let's go ahead and write this out. So I have y equals, so again, now when I'm stretching, I'm multiplying by a number, right? But since I'm compressing, I'm getting smaller. It's actually dividing. So if I compress by 2, I would actually have 1/2, and then times everything, right? So if I compress, I flip that number into a fraction, and now I can distribute. So I have y equals half of 4 is 2x, and then half of 1 is just half, right? So that would be my answer. Okay, same thing over here. I have my absolute value of x plus 1 and then minus 4. It is compressed by 3. So I have y equals, since I'm compressing, I take that 3 and flip it. It becomes a fraction. And I do my whole function inside, right? Just like we did before. And now I can distribute, but because absolute value, it has to go in front. And then I can do the times negative 4. So now I'll just go ahead and rewrite my answer. So I have y equals 1/3 absolute value, because my x plus 1 doesn't change, it can't. And then 1/3 times negative 4 is just negative 4/3. That doesn't divide, which is fine. I don't have to do anything else with it. It's just stuck as a fraction forever. So if you hate fractions, that's okay. We're not actually having to add or subtract with them. So that's it. That's your answer. Okay, and then last two down here. So same thing with the graph. Let's write the graph and see what we divide by. So it's kind of like stretch, but instead of multiplying, we're dividing. So my first one, y equals, my slope, I'm going, was that up 2 over 1? So 2x. And then my b is negative 4. And then my red one is y equals, my slope is up 1 over 1, so 1x. And my b is negative 2. So I want to know what I divide by to go from 2 to 1, or to go from 4 to 2, right? So of course for either one of those, I'm dividing by 2. So I would say compress by 2. So this is whatever you divide by. I don't want to say compress by half, because that would actually be a stretch. I don't want to go into the details of that, but if you understand, that's cool. But it's, the compress is the number you divide by. So yeah, I would be multiplying by half for these, but the compress, again, it's just the number you divide by, so be careful. So I'm dividing by 2, so I compress by 2. Okay? And the last one here, I have y equals, so my number in front of my absolute value is going to be 1, 2, 3 over 1. So I have 3 absolute value. And from the center, I move to the left, so plus 1. I can go up or down. So that's good. And then y equals, my slope here is up 1 over 1, so 1. And I still move left 1. So all I gotta do is figure out what I divided by to get from, or what I divide 3 by to get to 1. Well, 3 divided by 3 is 1, so I compress by 3. And that's it. Pretty easy. So on the practice, on the homework today, it is broken up into different sections so you can focus one at a time, and there should be some that are mixed up a little bit at the end. So yeah, I would definitely practice this if this is something that seems hard to you, and if you ever have questions, feel free to ask.